So it has to be on its own shard. We can just change this if statement to make sure that 10 is always directed to its own dedicated shard. So what this looks like then at the service level is, the way we manage this is basically using decorators. We have a read SQL decorator and a write SQL decorator. When a write SQL decorator is found over a method, basically this means that we want to do a write, so we want to connect to one of our masters, one of the shard masters. When we see a read SQL decorator, it means we want to do a read, so we're going to randomly connect to one of our slaves. Okay? This decorator takes in a parameter, which is basically a shard key. And what that does is it says, in this method, which of the parameters that we have coming in is the shard key. So what will happen is, when we call search for matchmaking, the game type is passed into our sharding function here, and that will basically connect to the relevant DB. So by the time we get into executing our SQL, this DB object here is populated with a connection to the relevant database. So we just don't have to worry, from a development point of view, how many shards there are or how it's even sharded. That can be decided after launch. I'm kind of stuck for time, so I'll go on a bit. I will basically just talk a bit about our, in general, I talk this is our core services here, but we have a lot of other technology, really, really cool technology in place that we use. And again, most of it uses Python. We have a web front end to all of our services as well. So if someone wants to go onto a website and find out how they performed in the last 10 games, they send a request, basically use Django for this, and that is connected to the same data sources that are servicing game requests. And they can find out how they did in the last 10 games without logging into their games console. We have a data warehousing as well, which basically harvests all the information